Histograms GCSE Maths Word Exam questions. This is an A-star topic. We'll start off with some grade A questions and move into the A-star stuff towards the end. There are 6 questions, and I'll try to cover all the different types of histogram type questions that come up on GCSE Maths exams. Now, the first couple of questions are going to be of the type where we're drawing out the histograms. Now, this method for drawing out histograms is only a grade A, and then we're going to do some comparisons of different histograms, and then we'll move on to questions where you're just given the histogram itself and no table, and you're trying to use the histogram to calculate how many people are in certain groups and things, which is the sort of A-star questions. Always histograms come in the last 2 or 3 questions on a GCSE higher maths exam because they're either A or A-star, or in fact both. So let's start out with a standard table. We've got the groups and we've got the frequency. This time it's called the number of boys, which is just the frequency. Usually it's called the frequency. Okay, to draw a histogram, we've got to remember that each bar on the histogram, it looks a bit like a bar chart or a frequency diagram, but each bar represents the area. Sorry, each bar, it's not the height that represents the frequency, it's the area of the bar, so how many squares it covers. And because of that, we don't have frequency at the side, we have something called frequency density. And the frequency density comes from doing the frequency divided by the width of each group, because the width times the height will give you the area, and that should be the frequency. Okay, so if we're looking at each group here, just look at the widths to start with. It's very important we know the width, so I'm going to just add that column in. Sometimes they add in extra columns to help you with these diagrams, but quite often they just give you the table and some space to do the working. So I'm just going to write the widths down. So widths are 5 to 10, the width is 5, 10 to 20, the width is 10, then 10, and then 5 and 5. So the frequency density is going to be the frequency, which is 1, divided by 5, which is 0.2. This is a non-calculator question, so these sort of calculations you need to be able to do without a calculator. 9 divided by 10, 0.9, 5 divided by 10, 0.5, 4 divided by 5 is 4/5, which is 0.8, and 1/5, which is 0.2. Okay, now we need to draw that. Now, it's quite tricky for me to draw with this pen on this computer, so I've actually pre-drawn it, and it should look something like this, and it goes from 0 to 5. And let's make sure we get it in the right places. I think it should be there. Right, okay, or thereabouts. So let's just talk through that. So the first bar goes from 0 to 5, and it is a height of 0.2. So in fact, is that right? So each square here we have 10 squares for 0.5, so each 2 squares is going to be 0.1. So yeah, that bar's a little bit high. I need to move it down a bit. So let's go down a bit because it should be 0.2. There we go. And hopefully the rest will be in the right place now. Second bar, there was nothing because it's 0. The next one's a 0.9, so we need to be 2 squares below 1. There's 1, 2 below 1. And that bar goes from 10 to 20 because it's 10 wide. And then the next bar goes from 20 to 30. And that's at 0.5, so it should be on the line. And then the next bar is 30 to 35, which goes to 0.8. And the fourth bar will be the same as the first one. Now, when people are marking these sort of graph type questions, they're not going to check every little bit. What they have is an overlay, a transparency, or if they're marked on a computer, an overlay that comes over the top of it, and they can match it up and see whether your bars are in the right places. But most of the marks come from this column here, the frequency density. You're probably only going to get about 1 mark for actually plotting it correctly from these values. These is where you get all the marks. So if you get 5 or 6 of these right, you're going to have 2 marks out of 3 already. Okay, the next part of this question is to compare 2 cumulative frequency graphs. So this is a new cumulative frequency graph for girls, and this was our original one for the boys, which would be on our page if we were doing the test. Okay, now we've got to compare those two. Now at GCSE level, when you're comparing distributions, there's only two things you need to think about. One is the average, measure of the centre, and the other one is the spread. Usually we use the range as the easiest comparison for spread. Now let's do the spread first because that's nice and clear. We're going from 0 to 40 for the boys, and the girls are going from 0 to 25. I know there's a gap here, but even if we take the 10 to 40, that's a 30 spread, and this is only 25. So the spread, the comparison there is the boys have a greater range than the girls. And that's a nice easy 1 mark. For the average, all we need to do is to say which one has a higher average. Now we have to decide what average we're going to use. We could use the mean average or the median. In this case it doesn't actually matter because the average for the boys is going to be in the middle here somewhere above 20, and the girls is down here clearly in between 10 and 15. So I'm going to use the mean average. The mean average, and we don't have to do any calculations here, we just have to say which one's bigger. The mean average for the boys is larger than the girls. And that's all we need for any comparison we do between any two distributions, not just on histograms, it could be on box plots or anything. We just need to compare a measure of the centre, the average, and a measure of the spread, usually the range, or possibly the interquartile range on a box plot. Okay, that's the first question done. Okay, second question of histogram worked exam questions. So this question, we have a table again with the groups and the frequency, and we have to draw a histogram for 3 marks to start with. It doesn't really matter what the question's about, but let's just read it anyway. It shows the weights in kilograms of 112-year-old Nearland boys. Okay, so to work out the frequency density so we can plot the histogram properly, we need to remember we need to work out the frequency divided by the width of each group. And the widths of each group are 5, 10, 5, 5 and 10. So our frequency density, remembering this is non-calculator, we need to be able to do these calculations without a calculator. 3 divided by 5 would be 0.6. 26 divided by 10, 2.6. 25 divided by 5 is 5. 30 divided by 5 is 6. And 16 divided by 10, 1.6. Okay, so now we need to draw the bars on. The first group goes from 45 to 50. Just to speed things up a bit, I've pre-drawn the bars, so let's put them in the right place, hopefully. Okay, that's fairly close. Okay, now let's just run through that. So 45 to 50, we have a bar going up to 0.6. Remembering to check our scale, so we've got 5 squares is 1, so each of these squares must be 0.2. So we need 3 squares going up for our 0.6, and then up to 2.6 would be 2 and 3 squares, then 5, then 6, and then 1.6 is going to be 1 and 3 squares up, and the appropriate widths. Okay, so that's 3 marks. A lot of those marks are for the frequency density calculations, so try and make sure you get those correct. Part B, estimate the number, how many Nearland boys weigh between 55 and 67 kilograms. Okay, so between 55 and 67 kilograms, 55 is here. Oops. Just move that across a bit. There we go. And 67 sorry, is here. So 60, each one of these is 1. So 65, 66, 67. Going straight up to there. So we want to work out how many boys are in this area under here. Remembering the area gives us the frequency. Now we could go through and calculate the number by working out the area of all the squares. Remember, we've not got a calculator, so this might be making life difficult for ourselves. If if we look at this bar here, this bar represents 3 people and there's 15 little squares in it. So each group of 5 squares, each group of 5 like this little block of 5, that represents 1 person. So we could go through and work out how many people these are, because these two are fairly nicely stacked 5 wide. This last one is a bit tricky, but we could go and work out that there's 6 times, actually not 6 because it's 5 squares for each one, so that's 30 high and 2 wide, so that's 60 squares there, so that should represent 12. But there is a slightly quicker way. If we actually look back at our table, between 50 and 60 we've got 26, and this section here is half of that bar. So that section there must be half of 26, which is 13. This section here is the whole of this bar, which was 25. And this section here is 2/5 of this whole bar. This whole bar was 30. So 2/5 of 30. And 1/5 of 30 is 6, so 2/5 is going to be 12. So we've just got 13 plus 25 plus 12, and that should add up to 50. So there'll be 50 people. Now you've got to be careful with that. You can use that method, it's quite good if you've got the fractions work nicely, but quite often you do use the squares to count up how many people there are. Okay, the next part of this question, again another comparison part. Let's bring in the graph from the previous question. It looks a little bit like that. And we've got to compare the boys from Nearland and the boys from Farland. Okay, if you remember from the first question, when you're comparing 2 sets of data, we need to look at the average and the spread. So the range is the easiest one to use. From the cumulative frequency, not cumulative frequency, from a histogram. So the average value here, that's quite tricky to work out. It should be around about here. We could actually calculate that exactly. Let's just see if we need to. I think the average on this one is higher. We could talk about how they're skewed if people are trying to be technical. But for 2 marks, all we really need to say is which one's bigger. So looking at these 2 graphs, I would say the average for this one is around about somewhere around about this bar here, and this one is probably nearer this bar here. So I think we'll go with Farland has bigger average, and we'll say mean average than Nearland. For the spread and the range, it's clear that Farland boys have a wider spread because they're going from 40 to 90 than Nearland, which is 45 to 80. So Farland has a bigger range than Nearland. Okay, and that's all you need for 2 marks. Okay, here we've got question 3. Now, we're starting to move from the mainly drawing and comparing type histogram questions to working backwards to work out what the original values were from the graph. Also a little bit of drawing, but also calculating estimates to other things. So we're going to use this information on the graph to be able to finish this table off and then complete the histogram from that. So the only thing we've got full information for is this first group, 0 to 20, has a width of 20. In fact, we could just fill in all the widths. So we've got 20, 10, 10, 20 and 40. So this group should have a frequency density equal to the frequency divided by the width, which is 20 divided by 20, which is 1. So that bar there is at a frequency density of 1. So 10 squares up is 1, that's going to be 2, that's going to be 3, that's going to be 4. So that tells us this bar here, between 30 and 40, which is 4.5 high and 10 wide. So to work out what the frequency was, we do the 4.5, which is the frequency density, times by the width, which is 10, which is 45. So this bar, we're 20 wide, and we're going up 3, so 20 times 3 is 60. So the frequency is 60. So we should have had a frequency density of 3, 4.5, 3, and 1.2. So the two bars that need to be drawn, so that's that one done. The two bars that need to be drawn are this second group and the last group. Now I've pre-drawn those. So I'll speed things up a little bit. So this this bar goes between 20 and 30 and goes up to 3. And this bar between 60 and 100 goes up to 1.2. 48 divided by 40 is 1.2. We have a calculator available for this question, so we can work those out if we need to on a calculator. Okay, so that's that one done. So that's 4 marks. Now the tricky one, work out an estimate for the median. The median is in the middle. So if we add up all these values to work out how many things we've got 203. Okay, now if we were talking about discrete data, the middle would be 203 plus 1 divided by 2, which would be 202. So we're talking about continuous data, which you tend to with group data, regardless of what it was originally. And this is time measured in minutes, so it should be continuous. We just half that value to get 101.5. So we're trying to find where the 101.5 value is. Now we know that there is 20 in here, 30 in here, and 45 in here, so that's 95. Now if we want to be very accurate, we've got to really try to work out what each square is worth, or how many squares we need for one. This group here, which is 20 by 10 squares, actually it's 10 by 10 squares. So we've got 100 squares here and here representing 20 things. So every 5 squares, every little group of 5 is equal to 1 person. So we've got 95 things here. We want to get to 101. So 96 would be there, 97 would be there, 98, 99, 100, 101. So this bar takes up 101. So that's up to the number 42, because each square across here is 2 minutes. And then we need that was 101. 101.5 would be somewhere in this section here. So I think our best guess is 42, not 4.2, 42 minutes. So that's where the median would lie. We'd lie on that line there, which is 42 minutes. Okay, question 4. Now we're moving out of the drawing histograms to the pure working out what the values under the graph represent. These are the sort of A-star questions now. So probably the last question on the paper, and before the other questions were probably last questions on the paper as well, or second to last question. So we've got a histogram. We got told this is the frequency. There's been no scale on here, so we don't know what these values are. But we're told 10 runners complete the race in under 20 minutes. How many runners complete the race? Now, my preferred method for this, I mean, some people would work out the frequency density from that information, and then do all the areas from that. I prefer just to work out some sort of proportion. So how many squares represents 1 people, or how many people 1 square represents, depends on how many there is. So if we look in this section here, I've marked on every 5 on the side. They weren't marked to start with. So this section here is 4 high and 5 wide. So that's 4 times 5, which is 20 squares. This section here is 16 high by 5, which is 80 squares. So these two sections, which is the stuff under 20 minutes, so 20 mins under 20 is 10 people, and that's equal to 100 little squares. So we can say one person equals 10 little squares. So if we can work out how many little squares are in this whole diagram, and we can just divide by 10. It'll tell us how many people there are. So we know there's 100 in that first section. This second section is 10 wide by 5, 10, 15, 21, 22. So 10 times 22, which is 220 squares. This third section is 25, 26, 27, 28, 28, and it's 10 wide, so 28 times 10. So 10 times 28, that's 280 squares. And this last section is 20 wide by 1, 2, 3, 4, 5. So that's just 100 squares. And we had our original 100 squares. So in total, we have 500, 600, 700 squares. Now we are allowed to use the calculator here, but I don't actually think we really need it. 700 squares. We know 10 squares is one person, so 700 divided by 10 equals 70 people. So the answer is 70. Now, like I said, you could calculate the frequency density and then just do the width times by the frequency density for each bar to work out how much each bar is worth. But there's no real need if this sort of calculation works nicely, which it does in this case. Question 5. Here we have another question that is an A-star question. No drawing of the histogram, it's already drawn. We've got to interpret what's going on underneath the graph. Again, we're not given the frequency density. We have to do our calculations based on the information we're given. We are told 44 members are aged under 30. So that's this section here and this here, under 30. That's equal to 44. So if we work out how many little squares are involved in this section, so it's 2 squares high by 10. So 2 times 10, which is 20 squares. And then this section here, 5, 10, 15, 16, 17, 18. 18 squares by 5 wide. So that's 90. So we've got 110 squares is equal to 44 people. So if we're going to work out how many are aged over 55 or over, if we work out what 1 square is worth, 1 square, we'll bring our calculator in for this one. So 44 people divided by 110, each little square is going to be worth 0.4 of a person. Okay, so if we can work out how many squares there are from 55 and above, now this section here is 5, 10, 15, 20, 25, 30, 31, 32 high and 5 wide. So we've got 32 times 5, but that's twice what we need because we only need half of that. We want halfway through. We want 55 to 60, and then a bit above. But if we work that out, 32 times 5, so it's 150 plus 10, 160. And we need to divide that by 2 because we only want half that bar. That's 80 squares. And this section on the end here is going to be 10 squares by 4, which is 40 squares. Now, notice the scale is 20, but all I'm interested in is what each little square is worth on this diagram. And I worked that out to be 0.4. So we've got 120 squares there. Each one's worth 0.4 of a person. So again, bring in our calculator. Could do that in our heads. Should be able to work that out. That's 48, but we'll just check it on the calculator. Yeah, 48 people. And there we go. Again, we could do frequency density and work out what the heights are on the frequency density and do the calculations from there. But as you see, I prefer to work out what each, especially if we've got a calculator available. There's no fear in this, but for the division and multiplications with small numbers, we work out what each little square is and we can do it from there by proportion. And here's the last question for this histogram section. Again, using the graph to calculate the values, much trickier than actually just drawing the graph. We're told 42 leaves measured 25 millimeters or less. So 25 millimeters is about here. And we're looking at this section in here and that part of that bar, so a quarter of that whole bar. So again, I'm going to work out how many squares are in here. So we've got 1, 2, 3, 4 by 5. 4 times 5 is 20 squares. And then this whole bar is 10 squares, 5, 10, and it's 5, 10, 15, 20 high. So we've got 10 times 20, which is 200 squares. But we only want to go a quarter of the way along. We're going to go 25, and that's a quarter of all that. So we want to divide that by 4, which is 50 squares. And 20 plus 50 is 70 squares. And that's equal to 42 leaves. So if we work out what one square is, one square, it's going to be 42 over 70, and that cancels down. If we divide by 7, we get 6 over 10, or 0.6. Again, this is calculate based, you could do this on a calculator. So 1 square is 0.6 of a leaf. So we want to measure we want to know how many leaves measured over 60. So here's 60, so we want this section here and above, so this bit in here. So how many squares is that? Well, there's 5 there, 6, 7 squares across, and 5, 10, 15 up. So 15 times 7 squares, and 15 times 7 is 105. Again, use your calculator to do these sort of calculations. And so that's 105 squares, so 105 times 0.6 will tell us how many leaves there are. Bring in a calculator, 105 times 0.6 equals 63 leaves. Okay, so that's 4 marks at A-star level. Interpreting a histogram, working out the area under the graph.